Hey guys, today's question is walking robot simulation. In this question, we are given with a 1D vector commands and a 2D vector obstacles. So in this question, as given, a robot on an infinite xy plane starts at point 0, 0 facing north. The robot can receive a sequence of these three possible types of commands. So if the command value, the current value at the command array is -2, then we will turn left. If the value is -1, then the robot will turn right. And if the value is between 1 to 9, then it will move forward k units as the any value from 1 to 9. The value will only be -2, -1 or from 1 to 9. It will not be 0 or any other value. And it is also given some of the grid squares are obstacles. So there are some obstacles in the grid also defined, and the coordinates of the obstacles are provided in the obstacles 2D vector as xi and yi. If the robot runs into the obstacle, then it will instead stay in its location. So for example, if robot is standing at 0, 0 and it is going upwards in the north direction, so let's assume k equals to 5, so it is going to 5 comma 0, but there is an obstacle at 3 comma 0, so the robot will go till 2 comma 0 only. It will not move forward because of obstacle, and then it will wait for the next command and will execute next commands. So that's all. Return the maximum Euclidean distance that the robot never gets from the ever gets from the origin squared. So we have to simply return the maximum distance that we can achieve in the square. So like if the maximum distance was 5 comma 5, so we will return the square, the sum of the squares. So 5 square plus 5 square, which is 50. Like in the example, the maximum distance was 4 comma 3, so we returned 4 square plus 3 square equals to 16 plus 9 equals to 25. For example, in this example, as we can see, command equals to 4 minus 1 3. So initially the robot starts from 0 comma 0 and moves north 4 points. So initially it was, let's say, at 0 comma 0. After first index, after first command, what will happen? After first command, the robot will move 4 points upwards, 4 units in the north direction. So the new coordinate will be 4 comma 0. After that, the next command is -1. So as in this given question, -1 turns right 90 degree. So it will turn right, which is east direction, and so it will run right in the second iteration. Okay, second command, sorry, right. After that, the value is 3, so it will move 3 units right. Okay, so after the third command, what will be the coordinates? 4 comma 3. So the coordinates are 4 comma 3, and we will simply square them up. So 4 square plus 3 square equals 25. That will be our required answer. So this is a simple simulation based problem. So like when you see any problem like this, what the first thing comes in our mind is to just simply make a hash map for the obstacles, and at every point check where is the leftmost, rightmost, uppermost or bottommost, the nearest, sorry, not most, the nearest obstacle at any point, so that we can directly jump to the minimum of the nearest and the given distance. Okay, so the given distance, which is k, but in this problem, as the value is very large, like let's see the obstacle's length is 10 to the power 5 and the coordinates is xi comma yi 3 into 10 to the power 4, and as there are 4 quadrants, so the total value will be around 60,000. So we need to make a 2D vector of 60,000 rows and 60,000 columns. So the memory limit will exceed, of course, so we can't use that. So we cannot do this question in O(n) complexity. So we will do this in n-log(n) complexity. What we will do? We can make a set, and another thing, we cannot make an unordered set because an unordered set doesn't allow the pair of values. Although you can make a separate comparator separate class for that and make an ordered set, but we will do this question using ordered set, because using an ordered set you can store values in form of pairs. Okay, and we will also make a vector of directions that we can simply as use in all questions 0 1 1 0 0 minus 1 minus 1 0 to move forward. And at every point, like if the values of k is 9, we will just simply move one by one 1 2 3 4 5 so on to 9, and we will check at every point if there is an obstacle. We will not move to the next value, and if there is not any obstacle, we will just increment the value of I and j by the direction vectors value correspondingly. So let's code it up. I will explain more while coding. Let's make the direction vector for our direction north, south, east or west. So for north 0 comma 1, for north 0 comma 1, if we move right it will be 1 comma 0, only the y coordinate will change. And if we move right again, then 0 comma minus 1, and if we move right again minus 1 comma 0, as simple as that for all the directions. So if we are moving right, we will just simply move the k variable from left to right, and if we are moving left, if the given command is -1, then we have to move right. If the given command is -2, then we have to turn left. So if we are moving left, suppose k was here, so k will move from here to here. Okay, and also we can't write k -1 modulus 10 because modulus 4 solely, so direction will not be changed by -1 modulus 4 in the second case when we are to turn, because compiler will not use negative values and convert them. So we will just simply write, instead of -1 we will write +3 modulus 4. That will be same, and there will no compiler issue in that. Let's make a set pair integer, and let's name it as st. After that, let's loop in our obstacle and push all the values in the set. So at least not in the O1 complexity, but we can access in the O log n complexity. So obstacles, just simply push the values, insert, we have to use the insert function in the set. So st.insert x0 and x1. Okay, so x0 comma x1, and that's fine. And after that, let's declare the variables k equals to 0, that is pointing to the current direction. So initially it is pointing to the north, the robot is pointing to the north initially, so k is 0 for this where it is pointing to the north. And let's take answer also for returning, and let's take I and j also for the current position of the robot initially at 0 comma 0. Now let's write for all commands, let's run a loop for auto x in commands. First we will check the value of command. So if the value of x is -1, as here, if value is -1, we have to turn right 90 degrees. So we will simply write the direction is holded by k variable, so k will be changed as k equals to k plus 1 modulo 4, k plus 1 modulo 4. Okay, now as if x double equals to -2, the second case, here we have to turn 90 degrees left. So as I discussed, we will not write k equals to k minus 1 modulus 4, we will write k equals to k plus 3 modulo 4 instead. K plus 3 modulo 4. Now in the else condition, it's not Now in the explanation we have the value of k from 1 to 9. Okay, the given value of the command, not k. So from 1 to 9 there can be any value of x currently. So we have to run the loop x times as we discussed. So while x minus minus, first we will check if there is the obstacle at the next value where the robot will move or not. So if there is the obstacle at the next value, we will just break the loop here. Otherwise we will increment the I and j value accordingly, and at every point we will update our answer at the maximum of the previous answer and the current value. So as student find, the values are, first value will be I plus direction k0, and the second value will be weight comma j plus direction k and second index. Okay, so if this value not equals to st dot n, that means we found that value in the set. So there is an obstacle at the next direction, next point that robot have to go. So we will simply break, the robot won't go to the next coordinate. Otherwise we will simply increment I and j as we can go to the next point. So I plus equals to direction k0 and j plus equals to direction k1. After that, at every point we will just simply update the answer. So answer will be, answer equals to max of answer, and the current Euclidean distance, which will be I square plus j square. So let's write I into I plus j into j. Now after this for loop we will simply return the answer. Sorry, return answer. Let's try to run this. Let's try to submit. So the code is accepted. Thank you for watching.